Hi, welcome to part 18 of the video series about laws of motion. In the previous question, we learned how to calculate the action-reaction forces between two objects. In this video, we are going to learn how to solve yet another type of question. A 3 kg block is connected to a 2 kg block by a light, inextensible string moving over a frictionless pulley. Coefficient of friction between the 3 kg block and the surface is 0.2. We are asked to calculate the tension in the string between the two blocks. Regardless of the shape of the diagram, if we are given two or more objects interacting with each other, the way of solving this type of questions is by starting to draw a free body diagram and then write an equation for each object. We can choose any object to start with, but generally it is better idea to start with the one with less forces applied on it. In this case, we start with the 2 kg object. There are only two forces applied on it: force of gravity pulling the object downwards, and the second one is the tension force acting upwards. In almost all the questions we have solved before, we were drawing a vector representing the normal force as well. What about this object? Why didn't we draw it? If we recall the first part of the definition of the normal force, it is a force applied on an object by a surface. There is no surface in contact with the 2 kg object. Therefore, there is no normal force exerted on this block. Net force is equal to mass times acceleration. Usually, in this topic, we consider the direction of motion as a positive one. The system is moving in a clockwise direction, hence the force of gravity on 2 kg object has positive value and the tension force on the same block has a negative value. Force of gravity can be calculated as mass times gravitational acceleration. Mass of the block is 2 kilograms and gravitational acceleration is 9.8 meters per second square. As a first equation for this question, we get 19.6 minus tension force is equal to 2 times acceleration. Now we are going to repeat the same steps for the 3 kg object. Forces applied on it are force of gravity acting downwards and the normal force acting upwards. Tension force is trying to pull the block to the right, and the friction force tries to opposite and accordingly acting to the left. According to the second law of motion, the net force is equal to the product of mass and acceleration of the block. Tension force minus friction force is equal to mass times acceleration. Formula of counting friction force is mu times the normal force, which in this case has the same magnitude as the force of gravity and is equal to mass times gravitational acceleration. Coefficient of friction is 0.2. Mass is 3 kilograms and gravitational acceleration is 9.8 meters per second square. As a second equation, we get t minus 5.88 is equal to 3 times a. Let's bring two equations together. 19.6 minus t is equal to 2 times a, and t minus 5.88 is equal to 3 times a. We can notice that while in the first equation t has a negative value, in the second one it has positive one, which means if we add these two equations side by side, these tension forces will cancel each other. Therefore, 19.6 minus 5.88 is equal to 2 times a plus 3 times a. 13.72 is equal to 5 times acceleration, which can be calculated as 2.744 meters per second square. As a last step, we can substitute a in one of the equations. Let's use the second one. T minus 5.88 is equal to mass times acceleration, which has the value of 2.744. Thereupon, the tension force is equal to 14.112 newtons. This was the last video where we were solving extra questions related to the laws of motion. In the future, we are going to try to solve past paper questions related to this topic. but we will do it only after completing videos about all capsule line topics for grade 12 physics class. All the best in your exams. Don't forget to subscribe and turn on the notifications in order to be updated about my new videos.